Hi, mathletes. Today we're going to use patterns to investigate number walls. So what is a number wall? Well, here we have 3 bricks, and you can see that there's a number inside each one, 3, 7, and 9. And the number wall is putting more bricks on top to form it's like a pyramid. So here's an example. And so we have our 3, our 7, and our 9 at the bottom of our pyramid, or our number wall. Now, the number in each of the new bricks is found by adding the numbers in the 2 bricks below. So the sum of the 3 and the 7 is 10, the sum of the 7 and 9 is 16, and sum of 10 and 16 is 26. So now let's create 3 different ones, and I call them 4 brick number walls because they're 4 rows. Here we go. And I want them to have a common base. So that means that the number at the bottom is going to be the same. So let's use 1. So we have 1, 1, 1, 1. In order to find the next row, we have to add the bricks together. So 1 plus 1 is 2, 1 plus 1 is 2, and 1 plus 1 is 2. And then for the next one, 2 plus 2 is 4, 2 plus 2 is 4. And for the top, it's the sum of the 4s, which is 8. Let's do another one. Oh, before we do that though, let's think about how does this connect to exponents? 2 to the power of 0, 2 to the power of 1, 2 squared, 2 cubed. Think about it. You don't have to come up with an answer right now, but we're going to look at this more toward the end of the video. So just remember that we're going to come back to this. All right, here's our next one. 2, 2, 2, and 2. So again, we're going to add them together. So the sum of 2 and 2 is 4. Then we add our 4s together and we get 8. And 8 plus 8 is 16. And for the last one, let's just use 3. Again, 6, 6, and 6, and 12. And then the sum of 12 and 12 is 24. Get the idea? Okay, so what are some of the patterns that you noticed? You might want to pause the video here so that you can look at this and come up with some of the patterns, and then start it again once you have them and see what I came up with. So what I noticed is that all of the numbers are even except for the bottom row. So everything else is even. And I noticed that an even plus an even equals an even, and when you add 2 odds together, you also get an even. I also noticed that the top numbers are all in the 8 multiplication table. And I noticed that the numbers in each brick are the same in each row. These are all 1s, 2s, 4s, 2, 4s, and 8, etc. And that the number in the brick above is doubled the number in the brick below. So doubling 1 is 2, doubling 2 is 4, doubling 2 is 4, doubling 4 is 8. So now let's create a 4 brick number wall using a common base, but this time I'm going to jump and I'm going to use variables. And a reminder that variables are letters in math. So here we go. So instead of putting 1, 1, 1, 1, or 2, 2, 2, 2, let's put the letter B, or variable B. So if that's a B, they all have to be B. And now we're going to, just like we did with the other ones, to get the second row, we're going to add them. So I get B plus B, B plus B, and B plus B. And when we have 2 B's, we can say 1B plus 1B. Remember that the coefficient is an understood 1 when there's nothing in front of the variable. I end up with 2 B's, 2 B's, and 2 B's. Now to get the third row, we say 2B plus 2B, 2B plus 2B, and that would be the coefficients 2 plus 2 is 4, so 4B and 4B. And then for the top, 4B plus 4B is 8B. All right, so here are our 4 number walls, the first 3 using numbers, and then the last one using our variables. So now let's write a rule in words connecting a number from the bottom row to the number in our top row. So let's the number in our top row right here. We have our 8, our 16, our 24, and our 8. And let's see how that connects to the bottom. So if this is 8 and this is 1, this is 16 and this is 2, this is 24 and 3, and this is 8, and this is B. I've noticed that if I take my bottom brick and multiply it by 8, I get the top brick. So in other words, 1 multiplied by 8 is 8. 2 multiplied by 8 is 16. 3 multiplied by 8 is 24. And b multiplied by 8 is 8b. So we can say the number in the top brick equals the number in the bottom brick multiplied by 8. But I don't want to keep writing that every time. So let's use variables to make this shorter. Okay, so here we're going to write our equation. So we'll define our variables first. The number in the top brick, let's make that n. Okay, so this stands for n. So instead of writing number in top brick, we can just use n. And let's use b for the number in the bottom brick. Okay, so here's our equation in words. Number in the top brick equals number in the bottom brick multiplied by 8. Now we can replace number in the top brick with n, because we said n equals the number in the top brick. The number in the bottom brick we can replace with b. And multiplied by 8, there we go, 8. So we can write it two different ways, b multiplied by 8 or n equals 8b. This is the way you will usually find it because, again, we want the coefficient in front of the variable. So now we're going to verify that our equation is correct to predict the number of the top brick if we have a common base. So remember that we always use two ways to verify or check that our equation is correct. And we start with one that is given. In other words, one that we've already done. So let's do the one that we've already done where the brick at the bottom was 1. And I'm going to use my equation, n equals 8b. Again, n equals the number in the top brick, and b is the number in the bottom brick, our common base one. And so we said it's going to be 1, so I replaced my b with 1, and n equals 8. And I know the equation resulted in the correct answer because it matches the number in the top brick of the number wall, 8 and 8. Now let's do our second verification. Remember, we have to test with the number that we haven't used in the pattern yet. So let's use a number wall with 5 as our bottom brick. So I'm going to create that. And again, the sum of 5s are 10. The sum of 10 and 10 is 20. So in this case, it looks like my top brick should be 40. So n equals 8b. N equals 8 multiplied by 5. Again, that's my number in the bottom brick. And the product of 8 and 5 is 40. So I know the equation resulted in the correct answer because it matches the number in the top brick of the number wall, 40 and 40. So I have verified my equation. Now let's try another kind. And this time, instead of using the same number in the bottom row of our bricks, let's use the numbers 3, 7, and 9, but let's mix them up. So I can do 3, 7, 9, 9, 3, 7, or 7, 9, 3. Really, what I wanted to change was just this middle number. So I needed 7 in the middle once, 3 in the middle, and 9 in the middle. Because a 3, 9, 7 is going to end up with the same result for our top number. Now I find the sums. So again, 7 and 3 is 10, 7 and 9 is 16, and 10 and 16 is 26. And the sum of 9 and 3 is 12, 3 and 7 is 10, and 12 and 10 is 22. And the last one, 7 and 9 is 16, 9 and 3 is 12, and 16 and 12 is 28. So what do you notice about the top number? Again, you might want to pause the video. Well, I noticed that the top number changes depending on the order of the numbers on the bottom. And I noticed that the top number is always even because even plus even equals even. In other words, that second row, the numbers are all even. So what is the arrangement of the numbers that gave us the largest total in the top brick? Well, it looks like this one was the largest with 28. So it looks like it was 7, 9, 3. In other words, the 9 was in the middle. And what arrangement gave us the smallest total in the top brick? Looks like this one, which was 22. So it was when 3 was in the middle, the 9, 3, 7. So how did the order of the numbers in the bottom row affect the value at the top brick? Well, when the middle number was the biggest, the top brick was the biggest. And when the middle number was the smallest, the top brick was the smallest. So that tells me that that middle number is being used to find both the numbers in the second row. So I use this 3 twice. I use it here and here, where these other ones I only use once. The same thing with my 9, and I used it twice instead of the 7 and the 3 just used once. So now we're going to complete this number wall. And because we're going to be using different numbers, we're going to use different variables. So let's use A, B, and C. So A, B, and C. So for the second row, it's A plus B. and then B plus C. Now remember, we cannot combine A and B because they're different variables. The same thing with B and C. And then at the top, we have A plus B plus C. Now in this case, I notice that I have two B's. They're the same variables, so I can say A plus 1, 2, 2B plus C. So now how does this help confirm our reasoning that the middle number is being used to find both of the numbers in the second row? Well, I saw here that this is the 2B. So you have a B here, and you can be using it twice. You use it here to the left and to the right, where the A is only used once and the C is only used once. Now we're going to create three different 3-brick number walls, but this time we're going to use consecutive numbers in the base. Notice that I keep changing the base. First, we used the base where it was the same number. Then I gave you 3 numbers to use. And now consecutive numbers. Just a reminder that consecutive numbers that increase by 1, or we call them our counting numbers, 1, 2, 3, 4, 5, 6, 9, 10, 11. So here's our 3 number walls. And let's use 2, 3, 4 to start with. So the sum of 2 and 3 is 5, 3 and 4 is 7, and 5 and 7 is 12. Then we can use 6, 7, 8. So 6 and 7 is 13, 7 and 8 is 15, and 13 and 15 is 28. And lastly, let's just use 1, 2, 3. So 1 and 2 is 3, 2 and 3 is 5, and 3 and 5 is 8. Okay, what do you notice about the top number this time? Well, I noticed again that they're all even numbers because an odd plus an odd is an even. And I noticed that the middle row is always odd. I also noticed that they're all multiples of 4. So how can we represent 3 consecutive numbers using an algebraic expression? So now we're going to use our variables. So remember, consecutive numbers are numbers that increase by 1, or we're our counting numbers. So let's use an example with 4, 5, 6, 7. And when we use our algebraic expressions, let's make n equal 4. So 4 is n. So if 4 equals n, then 5 is going to be n plus 1 because 4 plus 1 is 5. And 6 is going to be n plus 2. And 7? Yes, n plus 3, and so on. So now we can use this in our number wall. The first brick is going to be n. Then we have n plus 1 and n plus 2. We're going to combine them now to get our second row. So n plus 1, I have 2 n's. They're the same type of variable, so I can combine our like terms and end up with 2n plus 1. Then I have n plus 1 plus n plus 2. So I have 2 n's, but I also have my constants that I can add together. The 1 plus the 2 is 3. So 2n plus 3. And then at the top, I have 2n plus 1 plus 2n plus 3. So 2n plus 2n, 4n, and then my constants, 1 plus 3 is 4. So 4n plus 4. So what do you notice about the top brick? Well, I noticed that the coefficient, that's the number in front of the variable, and the constant, the number that's just a number, are both 4. I also noticed that the coefficient and the constant are both multiples of 2. So now let's create a number wall with our 4 bricks on the bottom using a consecutive number. So before we did 3, now we're going to do 4. So n plus 1, n plus 2, but now also n plus 3. So n plus 1, 2n plus 1 like we did before. The next one is the same thing too, 2n plus 3. But now we have n plus 2 plus n plus 3. So we end up with 2n plus 5. Okay, again, we have 2n plus 1 and 2n plus 3. So 4n plus 4, which was on the top brick of our last one. And then 2n plus 3 and 2n plus 5, 4n plus 8. And now we combine those 2 bricks and we get 4n plus 4 and 4n plus 8. And we have 8n plus 12. So how does the number of bricks on the bottom layer affect the top layer? Well, let's see. Is there a pattern? Well, let's organize our results in a table because sometimes it's easier to see them in a table. And we can use 2, 3, and 4 bricks on the bottom. Now for our 2, 1, I just took this first part of the one with the 3, and then these are the 2 that we just completed. So the number of bricks on the bottom, for this one I have 2 bricks on the bottom, and my algebraic expression in the top row is 2n plus 1. Then I have 3 bricks on the bottom, and my algebraic expression on the top is 4n plus 4. And 4 bricks on the bottom, and I end up with 8n plus 12. So what if I have 5 bricks on the bottom? Okay, well, let's look at that one. So here's one that I did with 5. And so I noticed that my top brick is 16n plus 32. Now, what patterns do you see in this number wall? I want you to think back to the beginning of this video when I was talking about exponents to give you a little bit of a hint. Well, I noticed that the coefficients are all powers of 2. That's the coefficients, the 1, the 2, the 4, the 8, the 16. So in this first row, I said 2 to the power of 0. And just a reminder, any number to the power of 0 equals 1. So that's a 1 in front of the n. In the second row, it was 2 to the power of 1, or 2. For the third one, 2 squared, which is 4. The fourth row, 2 cubed, which is 8. And the fifth row, 2 to the power of 4, which equals 16. Now let's see what patterns we see in the table. And again, I notice that they're coefficients. They're also the powers of 2. And so when we have 2 bricks on the bottom, I notice that the coefficient is 2 to the power of 1, or 2. When there's 3 bricks on the bottom, I know that it's 2 squared, or 4. When there's 4 bricks on the bottom, it's 2 cubed, or 8. And when 5 bricks are on the bottom, it's 2 to the power of 4, or 16. So you can see how these go together. The rows equaling the number of bricks. So without making a number wall, let's see if we can figure out the algebraic expression for the top brick when there's 6 bricks on the bottom. All right, let's think about what we know. Well, we know that the coefficients are powers of 2. So 2 bricks were 2 to the 1. 3 bricks was 2 squared. 4 bricks was 2 cubed. 5 bricks was 2 to the power of 4. So 6 bricks, probably 2 to the 5th power. 1, 2, 3, 4, 5. You can see that, right? So it looks like it would be 32 for my coefficient. So we could say that the coefficient is 2 to the power of the number of bricks on the bottom minus 1. Because when there's 2 bricks on the bottom, notice that this is 1. So 2 minus 1 is 1 for the exponent. 3 minus 1 is 2. 4 minus 1 is 3. 5 minus 1 is 4. And 6 minus 1 is 5. So 2 to the power of number of bricks on the bottom minus 1. So instead of writing number of bricks on the bottom every time, let's just write B. So we're going to define B as the number of bricks on the bottom. So now I can write that the coefficient is 2 to the power of B minus 1. So for example, if it was 4 bricks on the bottom, it would be 4 minus 1, or cubed, like that. Now n is going to be our first consecutive number. So whatever number we choose for our counting number to start with, that'll be n. We're going to keep that as n because this is going to be for any number. So the first term is, in this case for 5, it's 16n. When we talk about terms, those are groups of numbers and variables. And remember, they're separated with a plus or a minus. So in this algebraic expression, there's 2 terms. As a matter of fact, there's 2 terms in all of these. So my first term is my coefficient and the n. And my second term is going to be my constant. Okay, so here's my constant. Now the pattern for my constant is a little harder to see, so I'm just going to give it to you. It's going to look a little complicated, but we're going to break it down and it's going to be easy peasy. Okay, so we're going to use 2 to the power of b, but instead of b minus 1, we're going to do b minus 2. And we're going to multiply that by b, again, that's going to be the number of bricks on the bottom, minus 1. Okay, so here's our expression for finding the top row of a number wall. Wow, boy, that makes me look smart, doesn't it? It looks confusing, but when we break it down and know what the variables stand for, it's actually pretty easy. Let's test this out, okay? So Notice again, the red is going to be for my first term. The blue is my second term. Okay, so we're going to verify it. And let's use the one where the number of bricks on the bottom is 4. So B again is the number of bricks on the bottom. B is going to be 4 because we're going to verify the one that's in green. And here's my fancy expression that makes me look so smart. Okay, so all we have to do here is we're going to replace all of the B's with the number 4. Here we go. So 2 to the power of 4 minus 1, n, plus 2 to the power of 4 minus 2 multiplied by 4 minus 1. And now we're going to simplify this. All right, so 2 to the power of 4 minus 1. Well, the difference between 4 and 1 is 3, so 4 cubed n, plus 4 minus 2 is 2, so 2 squared multiplied by, and 4 minus 1 is 3. Now, this doesn't look too hard. We can simplify that. 2 cubed is 8, 2 squared is 4, and the product of 4 and 3 is 12. So 8n plus 12. And it verifies. There we go. We have it. So it works with the one that we've already done. Now, let's see if we can do it with 6 bricks. Okay, B is the number of bricks on the bottom. We're going to use B as 6. And here's our fancy expression, which we know is not hard at all. We're going to replace these 3 B's with the 6. Here we go. So 2 to the power of 6 minus 1 multiplied by n plus 2 to the power of 6 minus 2 multiplied by 6 minus 1. So 6 minus 1 is 5. 6 minus 2 is 4. And 6 minus 1 is 5. And now we're going to just simplify this. So 2 to the power of 5 is 32. So 32n plus 2 to the power of 4 is 16 multiplied by 5, which is 80. So our algebraic expression in the top row, when there's 6 bricks on the bottom, is 32n plus 80. So if we wanted to write this for any number of bricks on the bottom, again, B would be the number of bricks on the bottom. And there is our lovely expression that we created, that we verified that works. I hope this made sense to you. We went from something that was pretty straightforward to really abstract just in this one video. But hopefully it was broken down so that it made sense to you. And again, what a cool expression that we came up with. And again, we verified that it worked. So if you know what the variables stand for, it's actually pretty easy. So thank you again so much for watching.